All right, good morning, everybody. Quite a packed house here today, early in the morning, second day of the show. My name's Clinton Herget. I'm a principal solution engineer at Snyk, and it is pronounced like a pair of sneakers or sneaking around. We are a developer-first cloud-native application security platform, and I can get into a little bit about what that means. But I'm here today to talk about the software bill of materials and what that means in the sort of modern software development landscape. Obviously, a lot of conversation with President Biden's executive order and the understanding now that software is getting so complex that what we really need is an interoperable standard to be able to really understand what goes into a piece of software so that then after the fact we can take action based on that. So just to start with maybe a quick definition, sort of what is a software bill of materials. I think we should define it as the following. It's a complete, formally structured list of components, libraries, and modules that are required to build a given piece of software and the supply chain relationships between them. And I think each of these components is pretty important as we work through sort of why an SBOM and why now, and then what can we actually do about that to generate value in the security landscape as well as sort of the software development landscape more generally. Why an SBOM? Sort of why is this an important aspect of being able to establish the traceability of software? I really think it boils down to three reasons. If you look at intellectual property management, right, this is obviously a hot topic in terms of becoming compliant, whether they're export regulations, license compliance, obviously a huge aspect as well, in terms of understanding what are the components that go into the application, how are each of them individually licensed, and what does that mean for sort of the risk tolerance of the organization. Auditing, another big piece of this, right? You need to be able to provide an authoritative list of kind of everything that goes into a piece of software in order to become compliant from the audit perspective. But most importantly, I think we can think about software supply chain security, and I'll talk in a minute about kind of what a software supply chain attack entails and why this is something that we're paying increasing amounts of attention to. Vulnerability management, I think, relies on this concept of having an authoritative list of what goes into your application. You sort of need to know the ingredients, right? If you really think about a food product, I think that's kind of the direct relationship here. You can't understand the impact of that food on the person who's eating it without knowing kind of what goes into it, right? You need the visibility first before you can establish the effects of that particular product, in this case, a software product. End-of-life awareness also factors into this, right? Understanding kind of what components of the application are still being actively supported and which are not. Again, that might tie into kind of vendor license management issues as well. And high assurance systems obviously require understanding every component that exists there under the hood. From an asset management perspective, right, we can also think about the idea of search and visibility. I often like to ask kind of organizations, how many different versions of OpenSSL are in use on your containers, on your VMs, by all of your applications? And no one can answer that question today, right? Because we lack fundamentally this structured approach to what goes into an application and why is that important and how can we interoperate it between various tools. That can drive process improvements as well, right? How much productivity is being lost because you have hundreds of different versions of a particular Linux package in use across the organization? Can you drive standardization around that? What are some of the values associated with it? And that can only be unveiled by research, and that research requires this kind of fundamental understanding of what constitutes an application. But most importantly, I think the reason we're talking about this in a federal context is sort of why now, right? Like, what is about this moment that makes software bill of materials kind of a term of art? And certainly, these are not new conversations, right? The standards bodies that have been working on these issues for a number of years, going back probably 10 years or so, that have created some of these nation standards that we'll talk about here in a moment. But obviously, this has been a slow-moving process. What has created the recent conversation around SBOM has definitely been the executive order the Biden administration announced in May. And that fundamentally was in response to a number of these software supply chain attacks, right? SolarWinds being the most obvious example. A software supply chain attack fundamentally means an attacker injecting some kind of malicious code into one of the components that makes up the application. And because applications are becoming increasingly complex, it is no longer possible for an individual developer, say, to understand every component of that application. And that's precisely what happened in the SolarWinds example. Often, though, the supply chain attack is not an end in and of itself, right? It actually involves being able to exploit the supply chain in order to introduce things like backdoors, things like malware into an application so that they can be attacked later, right? It's a means to an end as opposed to an end in itself. And that's why the increased attention is being paid now, right? The Biden executive order ensures or recommends that the relevant standards bodies come up with this interoperable software bill of materials, and that is a requirement for any organization providing software to the federal government for all the reasons that we just talked about. So the NTIA has been taking the lead on this. They've been bringing stakeholders together for a number of years now to talk about kind of what this may look like in a very general sense, right? And this has been happening over the last several years, which has laid the groundwork for these recent conversations happening around the executive order. So the current focus essentially is defining these minimum elements, right? Like what is an SBOM that meets basic user needs, and then how ought those be consumed, right, when we're talking about things like vulnerability management and so forth. One example, and I think everybody has probably talked SolarWinds to death at this point, so we'll go a little bit further back. An example of a software supply chain attack that perhaps could have been prevented by a more open standard around software bill of materials relates to a JavaScript library called EventStream. And in 2018, the author of EventStream, which again is an open source project in use by certainly thousands of JavaScript applications, added a new developer and gave that developer commit or publish permissions to the repository. That developer added a dependency, right, to this library called EventStream, and that was, not seen as noteworthy at the time, except after that, another developer, in this case a bad actor, took over the transitive dependency and injected malware into it. Therefore, any application using the widely known and well-respected library EventStream now imported this malware into their applications. And without a way to track the software bill of materials, developers, software owners, customers of any potential product using that open source library would have no idea that that existed in their applications and that they were now newly vulnerable. So I think it's important to think through examples like that, right? And the common underlying note, I think, here is complexity, right? Applications are now becoming much, much more complex beyond the scope of an individual developer, a team, an organization truly being able to understand everything that's going into them. So if we're going to prevent these software supply chain attacks, the first step has to be knowing kind of what's in the box, right? We have to make the identification the first step until we can move to actually consuming them, making these bills of materials useful for making decisions about the life cycle of the application. And obviously the executive order has kind of created that spark for industry to come together around some of these standards, and that's going to have multiple ripple effects as anyone supplying software to the government is racing to fill that gap to satisfy the new requirements of the executive order. But fundamentally, the issue is that applications have changed, and the stack or the layers associated with building an application now are very different than they were, say, 10 years ago. When we think about the world of layered monoliths, right, relying perhaps exclusively or certainly for the most part on first-party code, everything developed in-house, right? That layered monolith got deployed to some kind of centralized IT stack, and it was managed by an operations group. That's been a very slow model, but also doesn't it's not particularly complex, right? What we've seen, obviously, with the arrival of DevOps, with agile development, with cloud, is that the software environment has become a lot more complex. It's not only being deployed much more frequently, in minutes rather than months, but because of that, there's much more reliance on these components kind of underneath the surface, right? You still have proprietary code. I think that's well understood. Every application is going to have a certain amount of that. But for functionality that has been identified as sort of undifferentiated heavy lifting, open source has really won the battle. And in fact, 80 to 90+% of a given code base of an application today comes from those open source dependencies. And if you think about this, this just makes sense from a developer perspective, right? If I need to implement functionality that is well understood, say a login function for my application, obviously all of the cost-benefit analysis there says I should go to GitHub and find a library that provides that login functionality or a hashing algorithm or whatever that common component is, rather than build it myself. It's going to be maintained by a community. It's going to receive security updates. I can bundle it in with a package manager, and that's what's going to enable that DevOps-style velocity. Containers also add another element to this, right? Now the unit of delivery of an application is not just the code itself. It's not even the code plus the open source dependencies of the application. It's essentially everything that application needs all the way down to the kernel of the operating system, right? So all of the libraries, the runtimes, the tooling that previously would have been provided, again, by that IT stack on some kind of a Linux server or a VM, now being provided inside the container. So those components now belong to the application. They don't belong to the stack that it's being deployed onto. But what's critical here is that it's increasingly developers who are responsible for making those decisions, right? If I'm a developer and I need to containerize my application, then I'm the one who's going to go out to something like Docker Hub, to a public community to choose that container image to build it on top of. And I lack that visibility into all of those Linux packages being bundled in under the hood. So the rapid development that things like containers provide, the other side of that obviously is lack of visibility, and that causes a new source of potential risk, potential vulnerability. Infrastructure as code adds another layer to this, obviously, as the configuration for the application is being bundled into the application itself, and it's developers who are responsible for writing that code, right? Those configuration files, the YAML files that are living in the repository alongside the application itself. So complexity is increasing everywhere, which means that the components of a modern software supply chain are also becoming complex. We've talked about a few of these already. I've got my application dependencies, and again, the issue there is not necessarily the libraries that I'm aware of that my application is relying on, but all of the libraries and the dependencies of those libraries and those packages and so on until you have these multi-layered massive dependency graphs. We throw around examples at Snyk of things like, I could have a Java application with 7 dependencies and 85 lines of code, and my application builds very happily. But that's because it's actually pulling in 600 different dependencies and millions of lines of code behind the scenes. And I have very little visibility into that as a developer. Container OS packages we've already mentioned, right? The libraries, the runtimes, the tooling that are being bundled in. The sources could vary, right? Oftentimes those come from the package manager, something like an NPM or a Maven. Often they're coming from the OS package manager inside the container, the apt or the RPM. But there's also things like unmanaged source files that developers are downloading, sticking in a vendor folder. There's unmanaged binaries potentially getting copied into containers. And there's code snippets, right, around things like going to maybe Stack Exchange and finding a solution to a problem, cutting and pasting that into an application. So there's lots of different elements of the supply chain that require this recognition. There are some emerging frameworks, and these are kind of across industry as well as open source groups. We have the Salsa, if you want to say it that way, as a product of Google. We have OWASP that has the SVCS framework, Microsoft with SCIM, and then the cloud native, CNCF rather, also has a list of best practices. So again, there are emerging conversations about what an SBOM should entail. We also have a number of, or really 2 emerging standards, and these really take it to a technical level in terms of what should actually go into an SBOM, how ought they be packaged together, et cetera. And the 2 kind of competing standards so far have been Cyclone DX and SPDX. SPDX recently received an ISO certification for the first time, but we believe that these 2 standards will both have a role to play in the conversation around SBOM moving forward. To kind of vastly overgeneralize, essentially, Cyclone DX is a perhaps slightly more open source oriented project, represents more of the software development community, whereas SPDX is a little bit more along the standards side, right? A product of the Linux Foundation. And it's important to point out that these are still works in progress, right? The SPDX v3 standard still has not been finalized, and there are still a number of potential additions, and Snyk has been very much involved in those conversations moving forward. When it comes to the components of an SBOM, what do we really want to know about that ingredients list, right? And these are basic questions about what goes into an application that we can answer now all of a sudden that we have these standards. Things like, what is this piece of software? What version is it? Where did it come from? What does it relate to in terms of other packages? How do we identify it? What is that unique identifier? Also, what are those transitive and indirect dependencies? What else is implied by bringing this application into another piece of work? Additionally, we can add, who does this come from? Who wrote it? When did they write it, right? What else is associated with this unique identifier? What other information might be useful to the consumer of this piece of software? Things like vulnerabilities that are known to be associated with it. Things like licensure information that enable decisions to be made based on the components of the application. Work is being done around being able to generate SBOMs, right? And the problem, though, I think, is this is typically where the conversation has stopped, is can we generate this? Can we tick the box for compliance reasons to say, we have now created a bill of materials for this application? There is definitely some good tooling here that can take a package manager format, for example, and generate a CycloneDX or an SPDX result. Maven is becoming increasingly mature, an example. So you can take a POM file, for example, use Maven to generate a CycloneDX SBOM, and there's some other associated tools there as well. This is all great work, right? But it's important to keep in mind that a package manifest is not an SBOM, right? There's additional information that we might require about those applications beyond what the package manager needs to actually compile that application and build it and actually get it out into production. But that's where things really start to get interesting, right? Because once you've generated the SBOM, then what can you do with it? And that's, I think, where we're really going to see some value moving forward. Because there's, as yet, not a real standard for how are these things stored. If you think about at scale, an organization that might have hundreds or thousands of applications that themselves have hundreds or thousands of components under the hood, how can those be adequately indexed? How can they be searched? How can we have information from the top down based on what is essentially a collection of JSON files, right? So there's a number of efforts at play here as well. And not really a good sense of how and where should they be stored. Do they get stored separately? So CycloneDX has a project called BOM Repo Server, for example. That's essentially an API web server-based project for accessing SBOMs with kind of basic CRUD level functionality. The OCI is also involved here as well, and there is a project underway to potentially include SBOMs in an OCI registry. I'm particularly interested in this one because that could mean things like requiring that when you push a container into a registry, you also associate the SBOM with it, right? And then perhaps signing those two pieces of information together such that you can generally verify that the contents of the container image are reflected in the SBOM. So again, everything is early here, right? We're not quite sure what that standard will be around how these things are stored moving forward, but interesting work is happening and the signals are good. But the final step, the third thing to keep in mind, so we talked about generation and then storage, but then what do you do with those SBOMs, right? Why are they useful beyond just checking that compliance tick box? Because you can do quite a bit with knowing the bill of materials of an application with everything that goes inside once you have that visibility. So at the end of the day, this is the real point. What value do you get from generating and storing SBOMs? And this is, can be the argument for why this is a bad idea, right? But I think it illustrates the problem here is if we're only thinking about SBOMs in the context of, well, we just need to generate that to, satisfy the executive order, I think we're kind of missing the point here. Because you can do things like write policies against an SBOM, right? Using something like Rego, the open policy agent, for example. You can prohibit certain packages, certain origins, certain authors from being imported into your application, specific licenses as well. Because there's not a great, wide storage in place of SBOMs, we're not seeing a lot of these examples yet at scale. But you can already build basic demos around things like preventing workloads from being deployed to Kubernetes clusters, for example, based on what is known about the application in the bill of materials. But then ultimately, at the end of the day, what we want to know is kind of, can we search based on that? Can I know, where am I using OpenSSL across all of my applications and what versions? What does that mean from a compliance perspective and perhaps most importantly, from a security perspective? Can I know for sure that I've tracked down every version of my application that has included a vulnerable version of a particular dependency? So what is Snyk doing today? As I mentioned, company name is pronounced like sneaking around or a pair of sneakers. We are a platform for cloud-native application security that is focused on developers. So we want to enable developers to take more ownership of security earlier in the process and to actually remediate issues as they're discovered. And so the concept of the SBOM has always been core to what we've been doing, because you sort of have to know what's in an application before you can give vulnerability reports, and certainly before you can offer remediation advice to the developer. So we've already developed tooling to take a result from Snyk, which parses sort of the package manager of the application, and generate an SBOM in SPDX format. We've made that an open source project. So all Snyk customers now have access to the tooling that can take that first step of being able to generate SBOMs. But we're also making that SBOM a first-class citizen in our APIs. And ultimately, the goal here is that the generation should be the boring part, right? Like, it should be the table stakes or the commodity or the undifferentiated heavy lifting. Because it's what you do with that that's important. So we're enabling our APIs, for example, to accept an SBOM as an input no matter where it comes from, and then create interesting results based on that. How many vulnerabilities are contained in that piece of software based on the SBOM? How many of those vulnerabilities have mature exploits associated with them? And most importantly, what can the developer do about that? What's the remediation advice associated with those vulnerabilities? So we're participating in these industry conversations around how can we extend that SBOM model beyond kind of the schema we talked about earlier to, excuse me, to incorporate a lot of these very security-specific pieces of information that are going to be required. That is generally called the Vulnerability Exchange, or VEX format, and Snyk is an active participant in those conversations with SPDX as well as with the Cyclone DX communities to refine the schemas and ensure that they're operable and providing interesting information from a security perspective. The final thing we're doing is we're integrating what we call FOSS-ID technology based on an acquisition we made recently to get at those unmanaged dependencies that we talked about. So it's relatively straightforward to say parse the package manager of an application or the package manifest and generate a list of those transitive dependencies. It's more difficult to say, well, what if the developer is pulling in code directly, right? What if they're just copying snippets into their code? What if there are unmanaged binaries on the container? So recognizing that this is becoming a subject of increasing concern, we made the acquisition of the FOSS-ID technology, which actually can identify those things like code snippets at the actual signature matching level, and are beginning to integrate that into the overall Snyk platform. So we're no longer reliant specifically on the package manager as the source of truth, because as long as it's in the application, it ought to be reflected in the SBOM. There's lots of work to do to get involved here in terms of writing client libraries to translate package manifests into SBOMs. The upstream generation is also a very important component, because ideally that SBOM should be an interoperable component that is a language that everyone speaks, right? From the developers to the cloud and every kind of technology in between, including the package manager, the build tooling, et cetera. But again, most importantly, it's the tools to consume them that are really going to drive demand, right? If we can take an SBOM and provide interesting insights, if we can make them searchable, and if we can make them storable, then ultimately that's where we're going to be seeing value. So the SBOM itself is is a means rather than an end in itself. Obviously, we need a lot more talk around this. We need to wait for these standards to emerge, but the work needs to be done today to ensure that that demand is there to meet the supply. So again, takeaways. SBOM's not an end in themselves. Once those standards are finalized, they should be boring. They should be undifferentiated heavy lifting. What matters is how they're consumed. And I can know things like how many vulnerabilities are in my application, what licenses are associated with those dependencies, what components of that application are end of life. Is my application in compliance? And then which of my applications contain this piece of code, this component, in all of that complexity that is known to potentially have vulnerabilities, potentially have issues, and only then will I have visibility across that entire landscape. That's all I have for you today. I wanted to thank everybody for coming to the early morning talk in this well-packed room. Again, we are Snyk. You can come see us on the floor. The company acronym actually stands for So Now You Know. So now you know a little bit SBOMs at least. Again, appreciate everyone. My name is Clinton Herget. Email address is up here on the screen. And I do encourage you to fill out the session survey at the end to give me feedback. Got a few seconds left here if there's an additional question or anybody wants to do a really brief deep dive. All right, sensing all of that enthusiasm about SBOMs, I'll take that as my cue. But thank you, everybody, and appreciate the time.
Thank you, Clinton.